In this lesson, we'll be learning how to graph systems of linear inequalities. So if you remember about graphing inequalities, there are some unique things that happen with these graphs. First, there is shading involved when you're graphing linear inequalities on a coordinate grid. The shading, if the inequality is less than or equal to, you're going to shade below that line. And if it is greater than or equal to, you're going to shade above that line. Secondly, you'll notice in these two graphs that we have dashed lines. The dashed lines, then, I'm going to move this over here. For the dashed or solid line, if it is less than or greater than, you're going to use a dashed line because that means all of the solutions on that line, or all the points on that line, are not solutions. And you'll use a solid line if it has the equal sign with it. So less than or equal to or greater than or equal to. Then you're going to have a solid line. So looking at both of these two equations or inequalities, both of them don't have the equal sign. This one is y is greater than 2x plus 4, and this one is y is less than 2x plus 1. The less than, notice the shading below that line because all solutions less than that equation. Think of the y-axis for less than, seeing the numbers that are smaller than where that line crosses. And since there's no equal sign, we have a dashed line. Over here, this other equation, inequality, we have greater than. So we're shading above that line because if you think of where this line is crossing the y-axis, all numbers larger than that are solutions, but anything on this line is not, and we note that with the dashed line. And it could be the case where our solutions cover multiple coordinates. It could overlap on graphs or the solutions to the system of equations, and it could be the case where they never actually overlap or they completely overlap. This is an example where they never overlap, so this is no solution. 1, because the two lines are parallel, and 2, because the shading is in the opposite direction. So when you're trying to graph the inequalities, remember how to graph using slope-intercept form, where you have your slope and your y-intercept. So this first one, this first graph, I'm going to change my color, and if it's y is less than or equal to, so note less than, I'm just going to make a note, I'm going to shade below because of the less than, and it has the equal sign, so it's going to be a solid line. So y is less than or equal to a negative 1/2 x minus 8. Slope-intercept form means that minus 8 is where it's crossing my y-axis. So that's my first point at a minus 8. And it has a negative 1/2 slope. So that means rise over run. I'd count down 1 to the right 2. So down 1 to the right 2 gets me to this point here. And now if I graph those 2 points, whoops, this is really thick. Let me change the weight of that. So I want to be able to see in case there's another coordinate there. So let's try that again. So there approximately is our graph of our line, of that first graph. So now our second equation, our second inequality, y is greater than or equal to, and if we graph greater than or equal to, greater than means we shade above. Notice I haven't shaded anything yet. I'm going to do that after. So shading above, and it has the equal sign, so it's going to be a solid line. And this time our y-intercept is at a positive 5. So it's crossing my y-axis at a positive 5 and also has a negative 1/2 slope. So down 1 to the right 2. You may notice both of them had a slope of a negative 1/2. So these two lines are actually parallel. So we'll have to see if there's a solution if they intersect. So graphing that second line. Now this is where we determine the solutions. We have to graph the shading. So on our pink line, the shading is less than, so below this solid line. That would be everything here, including that solution, or that anything on that line. So there is our shading for our pink inequality line. And the second one, y is greater than, so the solutions are greater than all of this. Greater than means we shade above. So we're going to shade above that line. And if you notice, all of the shading is our solutions. And since none of them overlap, this one actually is no solution, because this shaded region does not ever overlap this shaded region, because these two lines are parallel. So we would say for this one, no solution. Let's look at another example that does have a solution, that does have some overlapping values. So in this one we have y is less than 6. So with this one, there's no y-intercept over here. It's crossing, or it doesn't, it's not set up as slope-intercept form. It's just saying that y has to be less than 6. So this is just like the equation if it was y is equal to 6. That means every y coordinate would be 6. So this line is actually going through y is 6 on our y-axis, but it's a horizontal line. So in this one, if y is less than 6, it's a horizontal line. The only thing now, this does not have an equal sign. So we actually have to make this line a dashed line. So I'm going to change my color to white to make it so that it's still a straight line. But it's actually a dashed line for this one, meaning that the points on this line are not actually a solution to that inequality. So now let's take a look at our other inequality. We have y is greater than or equal to negative 3x minus 1. So it's crossing our y-axis at a negative 1. That puts the point right here. And it has a slope of a negative 3. So that means a rise of a negative 3. So down 1, 2, 3, and to the right 1. So think of it as negative 3 over 1. So you've got your rise over the run. Now we can graph this one. This one is a solid line because it has that equal sign with it. So if we graph this solid line, it's going through both of those points. I'm just going to extend it so that we know to shade underneath or greater than the entire value. Okay, so now for the shading. This time I'm going to shade kind of in the color for the solution. So our first inequality, y is less than 6. So all solutions less than 6 are actual solutions for this blue line. So we're going to shade everything below this line initially as a solution to that inequality. Okay, so pretty close there for everything shaded. So now for our pink inequality, it's saying that y is greater than. So the solutions are greater than what is graphed. So greater than means we shade above. So all of this shaded above. I'm going to change my color again. So above this line, when you're trying to figure out where to shade above, think about if this is a teeter-totter, you're sitting on it is above. So you want to shade everything above that line. And the parts of the graph now that overlap, that is the solution area. So everything right here that overlaps both colors, that would be a solution. So the ordered pair 4, 3, that's a solution. But the ordered pair negative 2, 1 is not, because it's only in the blue. So anything that is overlapping both colors would be a solution to both of the inequalities. So you have many answers with this one, not just their intersecting point. Whatever is overlapping for the solution. And this intersecting point actually is not a solution because this is a dashed line. Okay, additionally in this lesson, you'll be working backwards from the graphs. So just think about how you can write the inequality in slope-intercept form. So y equals mx plus b, but instead of an equal sign, you're going to have an inequality. So remember the rules. If it's a solid line, it has an equal sign with it. If it's a dashed line, it does not. And the shading, if it's shaded below, you're going to use less than. If it's shaded above, you're going to use greater than. So this dashed line, if our dashed line is our pink inequality, we could write our inequality as y is, and it's shaded below, so I'm going to have less than. It's a dashed line, so I don't want the equal sign. It's just y is less than. It's going through the origin, so my y-intercept is at 0, so it would end as plus 0, so we don't actually need that on there. And it's incrementing as up 1 to the right 1, up 1 to the right 1. So this is y is less than a 1x, or just y is less than x. Our other inequality, if I change the color so we know which one I'm graphing, so this blue one, it's a solid line, and we shaded above, so that's going to be y is greater than for that solid line, or shading above, and equal to for that solid line. This one is also going through the origin, but this time our slope is negative, because down 1 to the right 1, down 1 to the right 1. So this one is actually a negative 1x, or you could write it as y is greater than or equal to a negative x. One more quick example of writing the inequality from the graph. In this one, if we do our solid line first, we'll make that our blue equation. It's going through 7 as our y-intercept. It's a solid line, and it's shaded above. Above means greater than. So y is greater than, and since it's a solid line, we have equal to, greater than or equal to. The slope is between these 2 points, up 1, 2, 3, 4, to the right 2, so 4 halves. 4 halves simplifies to 2. So y is greater than or equal to 2x, and then it's going through a minus 7 on our y-axis right here. So again, we did the slope, 1, 2, 3, 4, a rise of 4 to the right 2, 4 halves, simplifies to 2, and it's crossing at a negative 7. Now our other graph, this one, our dashed line, it's going through a negative 6 on our y-axis, and it's a horizontal line, and it's not included, and it's shaded below. So since it's going through my horizontal axis, that means that the inequality starts off as y is equal to something, and since it's shaded below, y is less than, no equal sign because of the dashed line, and since it's going through a negative 6, y is less than a negative 6. So here are the two inequalities. Again, you're just working backwards from the inequality, writing it in slope-intercept form. And really fast, one last example. So if this is my pink equation, it's shaded below, that means less than. It's a solid line, so it's less than or equal to. So y is less than or equal to a slope of up 1 to the right 1, 2, 3, 4. So a positive rise of 1 over 4, and it's crossing at 2. So plus 2 for slope-intercept form. And the last equation on here, if we use this one as our blue one, it is shaded above, so y is greater than or equal to, because the solid line. And this one has a slope of from here to here, so up 1, 2, 3, 4, to the right 2, so 2 again, 2x, and it's going through a minus 8, so 2x minus 8. So again, working backwards using slope-intercept form, the tricky part is writing the inequality. Solid line includes the equal sign. The shading tells you which inequality. So less than is shaded below, greater than is shaded above.